Hello everyone. In today's video, I will be solving a problem based on Poisson's ratio and elastic constant. So, in my previous video, I have already explained about the Poisson's ratio as well as about the elastic constant.
So, this is the question. Here it says that a bar of 20 mm diameter is tested in tension. That means here a bar, this is a bar, and the diameter of this bar is 20 mm and is tested in tension. That means a tensile force is acting on this bar and it is denoted by the term P. So, it is observed that when a load of 37.7 kilonewton is applied, so this load is 37.7 kilonewton which is applied in this rod. So what will happen? The extension measured over a gauge length of 200 mm is 0.12 mm. That means this length, this is the original length, is 200 mm, and when this force is applied, then what will happen? The rod will get elongate. So there will be a change in length here, delta L, and it is denoted by the term delta L. So delta L is 0.12 mm, and contraction in diameter is 0.0036. Okay, so that means when it will get elongate, what will happen? The size of the bar will also get contracted. So delta D, that is the change in diameter, is 0.0036 mm. So here in the question it says that we have to find the Poisson's ratio and the elastic constant. Elastic constant is what? That is Young's modulus, modulus of rigidity, and the bulk modulus. So we have to find the Poisson's ratio and the elastic constant. Now these are the given datas here. Here the diameter, the original diameter of the bar is 20 mm, and P, the load which is applied in this bar, is 37.7 kilonewton. And if we convert this kilonewton in Newton, then we have to multiply this term with 10 to the power 3. Now the original length of the bar is 200 mm and it is denoted by the term L. So the change in length is equal to 0.12 mm and the change in the diameter is 0.0036 mm. So the area of this circle of this rod can be determined by this formula, that is pi by 4 into d square. So d is already given in the question, that is 20 mm. So when we applied here 20 mm, then we'll get this value, that is 100 pi. So now in this question what it says, that first we have to determine the Poisson's ratio. Okay, so the Poisson's ratio is denoted by the term mu, and Poisson's ratio is equal to lateral strain upon linear strain. So here what is lateral strain and what is linear strain? So lateral strain is the change in the dimension and linear strain is the longitudinal strain. Now linear strain is the change in length upon original length. So change in length is given in the question, that is 0.12 mm and original length is 200 mm. Then we'll get this value. And the lateral strain is the change in diameter upon the original diameter. So change in diameter is 0.0036 upon original diameter is 20 mm. So we'll get this value. Now we have to put this value in this equation. In this equation, then we'll get this value, that is 0.3. Now next is to find the elastic constant, and elastic constants are Young modulus, that is denoted by the term E, and modulus of rigidity, that is denoted by the term G, and the bulk modulus, and that is denoted by the term K. So now first we will find the Young's modulus, and This is the equation for finding the Young's modulus, and this equation is derived from the Hooke's law. So E is equal to, E is nothing but the Young's modulus. E is equal to P into L upon A into delta L. Here P is the load, L is the original length, A is the area, and delta L is the change in length. So after putting all the values here, we'll get this value, and this is for the Young's modulus. Now next is to find the G value. G is what? The modulus of rigidity. So we have already derived this equation in my previous video, so you can go and check it out. So now from this equation we can the value of G. So E is known to us, that is this, and mu is already we have already solved the value for mu. Mu is the Poisson's ratio. So if we put all the values in this equation, then we got the value for G is this one. Now next is to find the value for K. K is the modulus. So this relation is also done in my previous videos, so you can go and check it out. So here from this equation we can find the value for K. K is the bulk modulus, E is the Young's modulus, and mu is the Poisson's ratio. So after putting all the values in this equation, we'll get this value. So this value is for the K, and K is nothing but the bulk modulus. Thank you.